For you, I have one class, two classes pending. Data collection class is pending, and in between we have statistics and exploration classes there. Next class, probably I think we'll have it on Wednesday. On that class, I'll cover the data statistics and exploration, and if possible, we'll also cover data collection, right? But I'm just fast forwarding today's class. I'm going to discuss on visualization. So visualization is a very important topic. If you go for any job, people will expect you that you create visualization. Let me share my screen. Just give me a minute. Okay, friends, hope my screen is visible. Let's get started. This is a very interesting topic and it's an important topic. Um, okay, so what is visualization? In your mind, you visualize pictures, right? Likewise, if you want to show what you have in your mind, we use graphs in mathematics and so on, right? But with computers, as data scientist or data analyst, you have tools and libraries to prepare charts, graphs, maps, dashboards, so that you can communicate your result, right? For example, if I want to show you what is the gold price trend for the last 2 weeks, right? If I just give you a table, it's very hard to interpret. Or if I ask you what is the gold rate for the last 3 months, let's say, right? If I give you a table of list of dates for the last 3 months, and I ask you to check whether the price is increasing or decreasing, obviously you will say, sir, this is a difficult task, right? I have to keep track of, say, for example, August till this day, November, right? So from August 1, I have to keep on reading the day price, and it's very hard, right? But if I draw a graph for the price, x-axis is the timeline, and y-axis is my price, right? So it will be very easy, right? So what I'm saying is, if I draw like this, right? Here I have the dates, and here we have the price, right? If I draw for my gold price, if the chart goes like this, then you will say, sir, the price um in general it is going up, sir. It's not going down, right? The price is going up. So that's what you will say, right? So this is what visualization does, right? Whatever I'm explaining. So visualization is easy to find out the trends and patterns, group categories, and understand the distribution variation, highlight the difference between variables, relationship between variables. So there are so many charts you can draw. One is line chart, bar chart, pie chart, scatter plot, box plot, map chart, histogram. We'll go one by one. Without further ado, let me go directly. So if you want to install matplotlib, right? This is a package for visualization. Pandas is for data manipulation. NumPy is for numerical computing, right? Numerical Python, right? That's what NumPy is. So all these libraries are already installed on your Colab. So you don't need to worry about all these things, friends. Next is, first let's create a matplotlib. Let's understand what it is. Okay. Let me execute before explaining it. Let me execute and see what this code does. So as you can see here, it has drawn a very nice picture, a graph of X and Y values. X values, if you see here, friends, starting from uh, 1.0, right, till 5.0, right? So the values differ between 0.5, right? Whereas Y, on the Y-axis, uh, yeah, on the Y-axis, it's a 0. It starts from 0, and then it goes till 25, right? And so this point may be, let's say, 0, comma 2, right? Or 1, right? This point may be around 2, comma 4, let's say. So like you do in your maths class, it's the same thing, but you use graphics and colors. So you don't need to be afraid of all this stained diagram. Huh? Don't think like this is rocket science. This is very simple. What I'm teaching is ABCD of visualization. So first is we are creating a NumPy array. If you remember, we can create a NumPy array out of a list. This is a list of numbers, right? This is my list, right? Like you have your cooking list or shopping list. This is a list of numbers separated by commas, right? In Python, a list is a data structure. So I'm converting this list into a NumPy array. The way I convert is with the help of np.array function, right? So this will become my x-axis, right? Why do we go for a NP array? Because NumPy is very good for faster processing, right? And why I'm saying x into x to the power of 2, right? So it's square of x. That's what y is. So in other words, as x increases, y increases double the rate, right? So before that, if you note here, I am importing this matplotlib.pyplot, and I'm calling as a short name PLT or nickname or alias, whatever you call it as, right? So, and then this is our normal NumPy. This is just like your max equation. So, and then you'll say PLT. What is PLT? PLT is nothing but short form for this matplotlib.pyplot. So like NP stands for NumPy. And then I say plot, and then I say x-axis, y-axis. What is x-axis? X-axis will take these values. Y-axis will take these values. And then I'm just saying, what is the color I need to be used? It is green, right? And line still I'm saying, if I say like this instead of double quotes, then the diagram would be different, right? So it's kind of there is no gap between these lines, right? So instead of that, I can give a kind of a dotted line, right? And marker 0 is nothing but the small circle which you see here, right? This green point, right? That's called the marker. You can change the marker as you want. There are different options. We'll see one by one. So, and then this is plot title. Plot title is nothing but the title we use here on the graph, right? So if there is a graph, if there is no title, nobody will understand what you are trying to say, right? And X label, plot plt.x label, right? Plt.x label is for X, what is the label you want to use on the X-axis? Similarly, Y label, what you want to use it on. Whatever you give, it will print. It's like print statement. But this is, since it's a chart, we use this plot thing, right? And then we say plt.grid equal to true. If I say false, let's see what happens. And then you'll know what is true. So you see, there is no grid. There is no, you have studied 4 lines notebook on your pre-KG, right? Those kind of thing, or in your graph sheet, you will see that small grid lines, right? Here I'm giving grid lines. Default, it is the spaces are different, but you can reduce the spaces if you want, right? And then show the plot. So this will actually, this is all you're writing the code, but it will work only when you write plt.show, right, friends? So this is about constructing, drawing a graph, right? Now let's see. There are different kinds of a diagram I said, right? One is line plot. You might have seen this line plot in your research paper. If you read an article, you might have seen all this kind of line plot, right? Okay, just give me 1 second. I'm just going to stop the sharing. Just give me 1 second, friends. I think okay. Just give me 1 more minute. I'll refresh my screen again. Okay, so what is y is equal to x uh, to the power 2, right? It's x squared, right? Y equal to x squared, right? You cannot put a x square in computers, right? So for that, that's the symbol. Hope prime, yeah. No, I'm resharing. 1 second. I'm not sharing the screen. I told you. And now only I'm sharing. Hope my screen is visible. Okay. So prime, is your doubt clear? Why we say y equal to x? Say, for example, let me give an example here. let's say x is equal to 2 to the power 2, right? When we say, what would be the result? It's actually connecting. That's why it is taking time. Just give me 1 second. Okay, so I can say print x. Yeah. So hope this is clear, Prem, for you. Uh, when I say 2 into 2, it's multiplication. But when I say 2, double asterisk 2, it's exponent, right? Okay. 2 to the power 2, right? It may be 2 power 3 as well, right? So this time it would be 8, right? So that's what it is. So without further ado, let's see another program. So in this case, let me share my screen. This is, I'm importing the pandas library, and then I'm importing the matplotlib library. And then I'm creating some data here, right? As you can see here, this is a dictionary. How do I say a dictionary? It starts with curly brackets, right? If it is just comma separated values, then it's a set. But here I can see it has a key and a value, right? And the values are list of subjects, right? And the score is again list of scores, right? And then I create, I pass this dictionary and form a data frame. So this will create a table. Subject and scores are my columns. So math, science, English are my values, and so on, right? And then so now right now my data frame name is DF, right? Then I use plt.plot, and then I say DF of subjects. When I say DF of subjects, this will, the first value would be the x-axis. So if you select this and hover over, you'll get an example, right? What this is, right? What you can read the help, right? So you can see they are using xp is equal to np data range 0, 5. 0, 5 is x-axis. I mean, they are saying the minimum and maximum and what is the limits. We'll see that, and y equal to np dot sin of x and plt x comma y, right? So plot x comma y. That's what I want to say here. This first value would be my x axis. This second value would be my y axis, and marker 0 I want to explain. So without further ado, let's execute this and see how what it happens. So as you can see here, friends, math, science, English, x-axis, the name of the x-axis is subjects, right? And the name of y-axis is score. So this is student score. For example, my name is Arokia. This is what I've scored in my say for example 10th grade, right? Class 10, right? On maths, I've scored 85. On science, I've scored 90. On English, I've scored 80, right? Right? So this is what it is. Likewise, friends, if you see here, uh, so that's what I'm doing here. Math, science, since I've given 3 subjects, it has taken 3 values here and it is plotting, right? So far it should be good, I believe. I'll execute it once again so that, okay. Next is So I'm explaining all what it is. You can read it later. I have already explained this grid line with another example. You can use plt.grid. The diagram between, I'm just adding upon precept, like adding our idea upon idea. So earlier it's the same code. Only difference is how to add grid lines, right? So there is nothing new here. Anyway, I'll execute it. Next is you can read all these notes by yourself. Say, for example, if I want to add labels, right, or legends, what they call. What is a legend? If you see here, friend, we are adding a legend here, right? What is a legend? Legend is nothing but a label given to this line point, right? This is my line. What does this blue line represent? If somebody asks, you have no answer, right? From legend, you can say this blue line is nothing but a student one marks, right? On different subject, right? So this is what legend. If you want to add that legend, it's very simple. You will just say plt dot legend, right? So there is no new, nothing new code I'm writing, no innovative code here. Only thing is I'm just uh, same code. I'm adding some few things here, right? So here all these things I have explained: X label, Y label, title, and everything, right? So here I'm saying you have added title, but if I want to change the font size of this title, how to do it? You can easily specify font size is equal to 14, right? And likewise, for subjects also you can do that. X label, Y label. For every options, you can specify the font size, and you can also specify where you want that title to be. For example, if I want to print that student score here, as you can see here, it would be easy, right? Likewise, earlier diagram, it was hard for me to read. Subjects was underneath science, so it was not clear. If I put on the corner, it would be clear. Science is clear, right? Okay, so what is legend? Legend is nothing but don't think of legend as a big kind of a legend like Bruce Lee or some other person. Legend is what they are trying to say here is the label we add. We will come to the legend again, I believe. Let's see. I think legend where it is. Yeah. So here, I don't know who it is, right? Rashmi. Yeah. So here, if you see here, here we are adding two legends, right? There may be multiple lines. We want to know which line denotes what, right? That is what it is, right? In a science book, if you open class 6, 7, you will see this kind of thing, right? They will say label one, right? And then they will write one is eye, parts of body, for example, right? Number two, leg, whatever it may be, right? Number two. So you write now, this is called a legend, right? You call that as parts, but here legend is similar analogy I'm just giving. Legend denotes like what this line represents. So here, what do we infer? We infer that the blue line represents the mark of student named Alice, and the orange line denotes its Bob, right? So from this, what we can say, friends? What we can say here is we can say that who has got a good marks? Alice, obviously, right? From this, I can say if there are multiple lines going on, we'll see the topmost line, right? We'll see what is this line for stands for, which student it is, right? Imagine four students are sitting, right? We'll find out like which color it is, and we'll map it, right? So this is what legends are useful for, all right? So likewise, thank you. Next, we'll go back to our code. So this is what I was saying. You can move the label, right? Usually it will be in the center. Now you will write this course center. But if I want to move it here, what will do? Likewise, if you want to move it there, what will do, right? Likewise, student score, it is in center, right? This is fine. So how to do that, friends? You'll specify this attribute called LOC. We'll say LOC is equal to center for title and the LOC for X label, LOC for Y label, and so on, right? We have different parameter here, right, left, center, all those things are there, top, bottom, right, in case of Y label, right? So rest of the code, it's one and the same. There is no difference. Only these two lines I'm just adding just to see what will happen to those diagram what we are trying, right? You can so adding a legend to your plot is very useful, especially when you have multiple data lines or multiple categories to distinguish in the same plot, right? So as you can see here, friends. So how did we add? That's a very good question. Earlier, I think this I haven't explained to the legend. Yeah, so if you see here, we have to write two things here, friends. Let me circle it so that it will be clear for you. One is this one, right? On my plt.plot, I have to give a label name, right? After you, this is step one, right? Once you give the step one, the second step is you just write the statement plt.legend, right? This is step two steps. If you do these two things only, you will get this, right? So whatever you write it on the label here, that will be the same. Here, this is the, I'm saying that add those legends, whatever you have created on the plot, add those legends, right, friends? So I have made a clear note, so I want you to go through. Once the class is over, I'll share those notes to you. Next is adding a legend. Yeah, so here, if you see, friends, we are adding how many legends we are adding? For each student, we are adding one label, right? Let's say Alice, and this is Bob, right? Bob, I circle with white. Right, so if I want to add these two legends, as I said, this is step A. Another step is you have to say whatever labels you are given, if you want to display it, you have to say plt.legend. So that's what it is actually doing, right, friends? Rest of the things I've already explained in the previous diagram. Just showing like what are the different things you can do with the same plot, right? Say, for example, if you write a research paper, usually people with research paper, they will add this kind of a chart. So at that time, it would be very handy, especially when you are doing a final project in your college. If you add graphs and explain with graphs, then your external examiner will be very happy and you will get very good marks. And I'm talking about final project, right? Or okay. Another thing is, friends, we can change the position of these legends, right? That's what it is. Earlier it was here, right? From here I moved there, right? Here to here, right? So how did I did it, right? Sometimes If the line goes here, then if you add legend here, then it may not be useful, right? So for that, we have to position the legend. The way we position the legend is by just saying legend LOC equal to upper left, right? So if you want to know, sorry, you are saying upper left is there is upper right, right, all those things. Sometimes you will see the legends are added down, right? Yeah, so as you can see here, friends, let me draw the white. These are the possible values: upper left, upper right, lower left, lower right, right center, center left, center right. All those things are there. You can play with all this easily in your free time. So not only that, say for example, if I want to color the background of my legend, you can easily do that by saying legend upper left you said now face color is equal to light blue. So you have different options, different types of coloring. You can see the standard colors red, blue, green, all these things are there. Or you can choose an hexa code and specify that. Okay, so it is the same. You can, okay. You can also change the font size of the legend, right? Earlier it was small in size. Now Alice and Bob is very clear now in the diagram. Next is we can create a bar graph, friends. Right? Just give me 1 second. So what is a bar graph? You might have studied in your lower classes. Bar graph is nothing but drawing bars like this. If you want, you can draw bars. Right? If you say, sir, this color is not clear, sir, I don't like blue color, sir. Can we use some other color, sir? Yes, you can use. Right? There are different options available. So instead of blue, let's say orange and try. I'm not sure whether it will take. Yeah, orange is also there. Or gray. I'm just trying. I'm not sure whether gray color is there. Yeah, it is there. Right? So from this, we can draw a bar plot, right? So what does it mean, friends? So if I draw a line here, right, we can see that the student has got more marks in French and in science, right? Whereas he has got low marks in English, right? And yeah, so other than English, the marks are better, right? So how to create such a plot, friends? So before we were saying plt dot plot, right? But right now we are saying plt dot bar, right? So bar denotes it's a bar chart, right? So in this case, I'm adding two lists. One list is called subjects list, and the other list is called score. I use the first list for my x-axis and the second list for my y-axis, right? And then I'm saying the labels as scores and the colors as gray, right? So that's what I'm saying, right? Rest of the things you know for clear. So we have already executed it. So next, we go to the next type of chart. Next is pie chart. Have you seen a pizza? pizza is kind of a pie, right? You might have heard apple pie or pizza. Pizza, if I give you a pizza, if you're four friends, if I ask you to divide, you will divide it by proportions, right? You cut it into four slices. If I want to create such a pie like this, then I can usually use this plt.py. Earlier, we were seeing plt.plot, plt.bar, now plt.py, right? So in plt.py, we only have x-axis, right? X-axis is nothing but the scores. So for example, here are two lists. I'm saying the scores list will become my x-axis, right? So English is 80, 85, 90, 80, right? 90 science has got higher marks, right? So when I draw a pie chart, you can see 35.529 percentage, I mean, is the proportion on my total marks, right? So from this, I can clearly see science has greater marks, right? Okay, so and then we must understand what these things are, right? Auto PCT is nothing but what is the percentage, right? If I say 0.2 F, then then it means display the numbers 2 points later, right? So after two decimal, I want the results up to two decimal. So for example, if you see here, you see 0.33, which is after point you have double three, two digit. Likewise here 0.37. Likewise here 0.29, right? So the how it knows that we need two digits after my decimal point. How to say that we use this auto PCT, right, friends? And then the starting angle. Have you seen starting angle? Starting angle is 90 degree, right? You know what is a 90 degree angle, right? So I'm saying this is my pi. You start the slice from this here, right? Sometimes if they cut the pie, they'll ask, nah, do you want me to cut at this angle, or you want to cut like a diagonal kind of a thing, right? So we can depending upon our diagram, we can specify. It's better to go with straight angle, as you can see here, friends. This is right angle, and then from there it will go, right? Okay. I think colors, I'm saying we have three subjects, so I'm giving three colors here. And then rest of plot title and plot show, you know it, right? So as you can see here, friends, since we have given the labels, it is your drawing for math. It is specifying what this is actually it is, right? So next is line graph. This is a very important graph, usually used in research paper and in trend analysis like sales analysis. If you see here, I was giving an example earlier. If I want to know the gold, what is the gold rate for the last 1 year, let's say, right? Or starting from January, I can draw such a diagram and then I can draw it, right? I can plot like this x and y axis, and then I can specify. Uh, oh, this one, how the screen. Just give me 1 second. So this is the percentage you're asking now because we are specifying it. Auto PCT, right? As you can see here, auto PCT is the key parameter for displaying percentages, right? And then we are specifying like how the percentage should be. If I say 0.2F, it means 2 decimals after, right? Hope that answered your question. What is subject? What is auto PCT? That's what it is. Auto PCT is nothing but a parameter for displaying percentage, right? Okay, thank you, friends, for those questions. So right now, this chart is called uh, line graph, right? So as you can see here, yeah, so this chart is called line graph, right? So how to do it? We have already seen this plt.plot, x-axis, y-axis, and marker. Color, I'm saying it as blue, right? So this blue represents sales. So that's what the label I'm specifying here. And line style I'm specifying, right? So already we have seen an example related to this. So hope things are clear to you. Okay, next is how to draw an histogram. What is an histogram, friends? Histogram is you divide the data into multiple bins. Imagine I give you 100 chocolates and I give you 10 buckets. You know the water buckets we use to bath, right? So those 10 buckets I give, and I give, say, for example, 1,000 chocolates. I'll ask you to put 50 on first bucket, 150 on second bucket, third bucket is 75, like that, right? Likewise, the data, when we say the data, this data is split into multiple bins, right? For example, friends, starting from 72, we have just one record. The highest is found in this. What is this? Yeah, and eighth student has got high. Sorry, eighth students has got 91. Let's say 91 to 94. Let's say, right, and only one student has got marks less than 70 to 75. Right. So how to do this? It's simple. I give all my points here, right, and then I am saying plot dot list, right. So this will tell me, using this, I can say what is the scores, how many buckets I want, like bins, they call it as. If you see, count here, we divide the data into 10 buckets or 10 bins. And then color, I'm saying sky blue. And edge color, I'm saying black, right? So rest of the things are same. Here, for generating the data, I'm saying scores is equal to all these numbers, right? Next, last, we'll see scatter plot. What is this scatter plot? Scatter plot is like, for example, just give me 1 second. I'll switch on my fan. 1 second. Okay. What is bin 10? Let me go to that. Oh, bin equal to 10. So when I say bin equal to 10, it actually creates 10 bins. So let's say, just give me 1 second. I'm just trying to locate the diagram. Yeah, so this is the thing we are discussing, right? So when I say bin equal to 10, where it is, here it is, right? When I say bins is equal to 10, here if you see, we are giving only x-axis, right? When we say bin equal to 10, what happens is it will create 10 bins. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So you can decide how many bins you want to the data to be divided, right? Right now, the data is like this, right? 85, 85. So there may be so many numbers, 50 students marks, right? Okay, we were discussing about scatter plot. Scatter plot is, say for example, we have two lists, study hours and then exam scores. We want to know, is my exam scores depends upon my study hours. What do you think, friends? I want to know your feedback. Is my exam score depends on my study hours? Yes or no? What do you think? All right. Uh, Say, for example, if I study 50 hours, it doesn't mean I'll get 100 marks. If I study just 30 hours, does it mean that I'll get only 90 marks? Right? This is my question. What do you think? Yes or no? Can you type? Right? So you find it very difficult to answer this question, right? But based on this point, we can say whether the study hours are important for exam scores. So, for example, here we have study hours are 1 to 10, and exam scores are, it is growing in nature in the order of 5, right? Plus 5, right? So, hence, we get kind of a upward trend kind of a thing. So, this is what the scatter plot is useful to show the relationship between two variables. In this case, exam scores with the student hours and so on, right? So, how to do that? We are specifying the x-axis and y-axis here. Once we specify x-axis and y-axis here, we'll set plt.scatter. Before we were using list plot, pi, pl plot, and then so on, right? But right now we are saying plt.scatter, and then we are specifying the x-axis study hours, y-axis exam hours, and then the color we want to display and the marker, right? For each student, right? We have some 7 minutes more. I'm going to start Seaborn and then I'll stop when the time is up, right? What is Seaborn? Seaborn is similar to Matplotlib, but you can do more with Seaborn with simple steps, right? It's also a Python library. With this, you can easily create visualizations with less number of code and better looking and more informative, right? So, for example, using Seaborn, it has support for statistics, better scaling. It can work with pandas, simple syntax. You don't need to remember hard syntax like your Java paper, right? And then it also has sample data like penguins, iris, and tips, right? So what is the difference between Matplotlib and Seaborn? Matplotlib is for when you want to create a bar plot, you have to do manual grouping. Whereas Seaborn, you can just write sns.com plot, it will do easily, right? And shading and colors is also good in Matplotlib, sorry, in Seaborn, because Seaborn is written on top of Matplotlib, right? So using this, you can create KD, kernel density estimation, box plot regression, and so on, right? So with this, I'll stop. Before we go to dive into Seaborn, I'm just going to, because it's a topic by itself. So with this, I'll stop. If you have questions, you can ask me now. If there are no questions, I would like to thank you for your time. And we will connect on Thursday. We'll finish off Seaborn and the remaining questions, right? In the meanwhile, I will share my notebook to you on Matplotlib. I want everyone to try out. That is the way you learn, right? Not attending class alone. Attending class is one part, but you have to practice, right? I'll share it immediately as soon as possible. So I would like to thank you very much for friends for joining on this Monday night. I know it's a very hard time after your college classes, hectic work, or maybe you may be working in a part-time job, right? So thank you, friends. But if you have questions, you can ask me. Else, we'll stop the recording.
Recording stopped.
Yeah, Seaborn is available in Google Chrome. Okay, so I can give you the Google YouTube link right itself, right? Just I'll type it on chat because I'm just going to search on Google only. I will tell you. So I'm going to paste this on the chat. This is a very good video. You can watch it. Everyone can click it and watch how to use Google Chrome. So if there are no questions, friends, you can